Speech Pitch by Iska Sak.
Hey there, and welcome back to Speech Pitch by Iska Sak. I'm Pascal Hacker.
And I'm Spyretta Leivaditi, and we will be your hosts for this episode.
Today, we are very happy to have Florian Eyben. Florian is the creator of the openSMILE acoustic feature extraction toolkit. He's one of the founders of audEERING, a company initially created around openSMILE and focused on speech expression recognition. And as a small disclaimer in the beginning, for the audience that doesn't know me yet, I'm also belonging to the audEERING family. Welcome to Speech Pitch, Florian.
Thank you, Pascal. I'm very happy to be here and speak today.
So please tell us a bit about your background and how you got into the field of speech analysis in general, Florian.
Absolutely. So that is, I think, a longer story, but overall, I'm in this field since 2006. My background is in electrical engineering. I studied that at TUM, which is Technical University of Munich. I always had an interest in electronics, in making things, circuits, programming computers, and I also had an interest in audio in general. So I love music. I worked actually as a hobbyist DJ, and I think I was not the person who was a musician, so I'm probably not really in any sense musical or talented with playing instruments. But I like to listen to music, and I was fascinated by the technology. So any light effects that you have or editing of music in some way. And through that, I then came to my bachelor's thesis topic. That was about tempo detection in music, and it led to an ICAST paper because we also included dance style recognition. So whether it is a cha-cha-cha, waltz, tango, and we used machine learning at that point. And that is how I also met Björn Schuller, my then later PhD supervisor, through that task. And yeah, I can go further and tell you more about that journey if you like.
Actually, of course, we are. My next question was why you decided to do a PhD, and how did the original idea, did it came to you? Did it change? How did it evolve during the time, until from the beginning till you defended your thesis?
Yeah, that's a very good question. And I think, the whole idea, it was not like saying, hey, now I got the idea to do a PhD. But while I was studying at TUM, I was also giving some tutoring exercises for some courses on signal processing, circuits design. And I just liked also to teach and share knowledge with students, and also understand some topics this way myself better, because whenever you teach and whenever you get into a topic deeply, you also deepen your knowledge. And I really liked that way of working. And I did not have really a vision to say, hey, I now want to go to a big company and start working there. So I thought, well, what do you do? Stay at the university and do some teaching. That means do a PhD, doing research and teaching. So then I just didn't yet have a position, but it evolved a bit naturally. As I said, when I did my bachelor's thesis on the dance style recognition, I met Björn, and he was my supervisor for that thesis. And I mentioned to him that, yeah, of course, I'd be interested in a PhD. And he was also at the beginning of his career. So he himself had finished his PhD and was now having his first European-funded EU FP7 research project called SMAIN that he had got granted. And he had 2 positions for PhD students at TUM through that project. The project was about speech processing. So in order to prepare for it, I already used the chance to do a master's thesis on the topic of keyword spotting and detecting of non-linguistic vocalizations, such as laughter, sighing, breathing in speech signals. And that's how I got into the speech field, basically. And I was still always fascinated by the machine learning aspect, trying to understand signals that for a computer seemed absolutely complex. but for a human, so natural and easy to understand. And that really drove my passion to say we can make algorithms that can decode human expressions and that can understand what we're saying quite naturally. And that basically is what I was doing in the CuRRENNT research project at TUM during my PhD. Then, you asked me about how it all evolved during doing the PhD. You learn some things when you do your PhD that maybe you hadn't anticipated before. But overall, I think it's a really, really good experience. So you get to do the research. You also do teaching. And as I said, I really liked that, to do some tutor exercises and also spend some time in really preparing some material in an easy to understand way. But then also you notice that when you work in academia, it's publishing, getting grants, of course, and publishing. But then some people leave, they finish their PhD, and whatever they did is somewhere on a server, but it's really hard to kind of grow some knowledge in a team and really build up some significant IP that's being reused. So basically the IP that you build is the papers that you publish, it's the citations that you get, it's others following you, it's maybe open source software that you make to fuel the community. But especially the open source aspect, that when I started the PhD, that was 2008, it was not that much as it is now. So now you go to Hugging Face, you go to GitHub, and you get almost everything. And it's more or less become a habit that when you publish paper, if you have some impact work, you also release an open source implementation with it, and that you really have a lot of reproducibility. Back then, 2008 to 2010, that was not so common. So you had published your paper, you had read some paper of somebody else, but you were trying to implement the methods of the other people, or you would ask them personally. You would say, hey, can I get your code to try it out? And then if you're lucky, you could get it to run. So it was a bit of a different culture. And that's where basically the idea also for openSMILE was born. Because in the CuRRENNT project, we had the need to deliver software to detect expressions from the voice in real time, but we also had to process data that was already lying around many, many hours, larger databases, kind of like in batch processing. And we already had some tools at the Institute, and they were not perfect. So they were slow to run. We had some scripts. It was not very efficient to compute things. And definitely it was not easy to integrate it in a real-time way. So as I also had done a lot of work in C, C++, also for my bachelor's thesis. I actually did the crazy job to implement all the signal processing, everything in Scratch in C. Was for me kind of an exercise to do, maybe because I hated to use dependencies, which change every now and then. But then nonetheless, we said, okay, let's make a clean architecture and write something that is sustainable and that we can use in the project. And Björn also suggested then let's publish it. Let's make a toolkit to say we're the first to make a feature extraction toolkit for speech expression analysis and music analysis together. Because this was also one point. There was one community doing music information retrieval. There was another community doing ASR or speech processing. And they had individual different toolkits. So actually the idea of openSMILE is to unite both worlds. So to take all the features that are known from audio, so to take features that are commonly used in music processing, like chroma features, and then to take other features from the speech world, like MFCCs or pitch of the voice, and dump this all in one big toolkit. And then also Björn's initial research on feature brute forcing was added to it. So feature brute forcing means you have a few low-level features like pitch, loudness, or MFCCs, which is a time series. And then you try for some segment of a variable length, 1 second or 3 seconds, you try to map those features into one single fixed dimensional vector. And thereby, you can actually explore a lot of combinations. So you can take 10 low-level features times 10 functionals or summaries, how they were called. And for the functionals, you can imagine it to be the mean, the standard deviation, or some other metrics describing how the time series looks in some statistical way. And that all went into openSMILE, and that laid also at that time the basis for the expression analysis of the voice and for overall what we did in the Semaine project from the analysis side.
Oh, perfect. Yeah, thanks so much for for this very nice and comprehensive overview. And I think it's quite a journey and quite a good job summarizing several years of PhD struggle and sweat, I guess, in such a short time. So you already transitioned very nicely to openSMILE. So that's also on our agenda because that's, I think, what is very prominent and still remains nowadays from your PhD in the sense. It's a very, very popular toolkit. So you gave already some summary integrated in PhD topic. Is there some other aspects that you would add to give the audience who has not maybe come in touch with it yet some quick overview of how you would describe openSMILE?
Sure. So openSMILE is, as I already said, an audio feature extractor. So basically it has a collection of a lot of signal processing algorithms that compute various known parameters from the audio signal. And it can do this feature brute forcing, as I had described. So basically combining low-level audio features with summary statistics or so-called functionals. And that way, openSMILE can extract basically an unlimited amount of features. There are most notably standard feature sets, such as the one that was used in the Interspeech Compare 2016 challenge on paralinguistics. It's named the Compare 2016 set. And there's also the GMAP set, where GMAP stands for Geneva Minimalistic Acoustic Parameter Set. And those standard feature sets enable researchers to not having to think about, hey, writing a config file, extracting some features, but just saying, hey, we use a standard feature set which other researchers have used, so it's easy, transparent, and reproducible. And then maybe from that set, we select a few features and run our research on it, or we take all the features and find out which of them are relevant in a certain experimental setting or certain task. And that, I think, really made this topic of feature extraction much more standardized, so that you don't have to share any scripts for other tools or share code where you can make errors. Basically, you just run openSMILE with a config file and you know that you would get the same result as somebody else. And you can easily describe this in a paper, cite openSMILE, cite the respective feature sets. And there's also, of course, a documentation, which is called the openSMILE book, which lists all of the features. And I mean, just for the sake of completeness, I'm often asked, hey, do you have something that describes how these features are computed, describes the algorithms behind it? Because obviously the 4-page paper that we made when openSMILE was introduced cannot describe all the algorithms in detail. Yes, this exists. It's basically my PhD thesis. So when writing up my experiments and everything that I did, I figured out, well, I need to describe all the features that I've been using and not just say, hey, there's a set and a list of names of features, but I need to describe what's behind them and how the theory works. So I compiled all the equations and all that. That's available in my thesis, and I think maybe we can link it to the podcast if needed.
Sure, that sounds like a good call. Yeah? And one small interjection here that just came to mind. I mean, we're using openSMILE as a term so easily also so readily, but it's actually an acronym, right? An abbreviation. So what does it stand for actually?
So it stands for Speech and Music Interpretation by Large Space Extraction, whereby we mean feature extraction.
That's quite a mouthful, yeah. But yeah, no, thanks. That's good to know also in the back what
But you know how acronyms are made, right? So you actually know how you want to call it. So you know the acronym first, and then often you find words that match it. And in this case, it was perfect because we just started with speech, with music, and then we're looking for a nice word. And that is where smile came up.
Reasonable, yeah, absolutely. So like going a bit further toward openSMILE still, I think you provided a very nice overview, and yeah, it's the one of the standard instruments that's being used if you do analysis for just acoustic feature, or just acoustic speech analysis. And another big tool that is out there is PRAT, right? So could you give some brief overview or some brief comparison from openSMILE to PRAT and similar tools that are out there?
Yeah, absolutely. I mean, PRAT is an excellent tool. And in fact, PRAT was also used by Björn's group at TUM before we had developed openSMILE, and also for certain things, it's still being used. It's an excellent tool for phoneticians, for linguists, to dive deep on a signal, because PRAT also provides a lot of visualization algorithms in there. PRAT has an ability to script it, so to write PRAT scripts, and to then automate your feature extraction in some way. But with all that, writing a PRAT script, it is not super fast and efficient. And that was also one of the reasons to do openSMILE in a different way, because the Compare 2016 feature set, for example, it has over 6,000 features that we compute based on almost like 100 low-level descriptors. And computing all these individual features in a meaningful amount of time. Back then, 2010, we did not have super high computational power and GPUs, so it was a different story. And also for the CuRRENNT project, we needed low latency real-time interaction. So we needed the results of the expression analysis to be there more or less instantaneously after you had finished your speech turn, and not wait 2 seconds for some pipeline to start and run. That's actually what, together with the standard sets, I think openSMILE is for. So if you just want to run a feature extraction on a larger scale, want to build something in real time, and use standard sets. But if you want to investigate single features or even look at other features that we have not implemented in openSMILE, because it's not complete. So I said we wanted to collect everything we find, but of course, there have been many more publications and variants of features being implemented and research being done in phonetics, which we have not all put into openSMILE, because sometimes also you can't process it online, but sometimes it's a two-pass algorithm, so that you do some processing after you have the whole signal, you do some more processing or some calibration. And PRAT offers such capabilities to work a bit more with the features, and I think that's where you then should actually go to PRAT. But if you want to go to scale, then I think openSMILE is a good candidate.
Thanks a lot for this very nice overview, and it's quite a good point to distinguish PRAT and openSMILE, especially like this back then required real-time component is a good argument for openSMILE indeed. Relatedly, how would you see the relevance of openSMILE in nowadays times? Like now it's 2024 when we're recording this, and 2010 is 14 years back, and we have now the rise of large language models and deep learning in general, end-to-end systems. Could you please comment briefly on the role of openSMILE in today's research landscape?
Yeah, that's a very, very good point. Oh my God, 14 years, right? That's quite a time frame here. But I like the idea of end-to-end models. And I mean, back in 2010, we did simply not have the compute capabilities on all that. I remember that at TUM, with a colleague together with Felix Wieninger, we developed the CuRRENNT toolkit, which was called CUDA Recurrent Neural Network Toolkit. There was a predecessor of it called RNNlib, which was implemented by Alex Graves. He's actually now, I think, still with DeepMind. And we had worked with him at TUM, and we had used the RNNlib to train LSTM networks for some tasks, which really showed good results. But it took a long time to train. So back then, first people were starting using NVIDIA and other GPUs from AMD or something to train neural networks more in parallel. And then Felix led the development here of this CuRRENNT toolkit. And that also led to massive acceleration of the research we could do here. So we were quite early on in this space. And later on, Björn also did research on end-to-end models quite early on. So in the mid 2010, so 2016 around, I think, was one of the papers. This whole field really accelerated with computing power that we have. And I believe also, I mean, although I invented and wrote openSMILE, that whatever we have in openSMILE is not complete, and it's just the version of somebody doing the algorithm how we should represent audio and audio features. So definitely end-to-end has a great upside if we have a lot of data, so that the model can learn its own representation and structure of the data in the world, and we don't impose a limitation with the features. And that's what we're seeing, what is happening. And that's where we get the next level in accuracy and naturalness in such technologies. The feature extraction still, I believe, has its value because either we can use it as a baseline to compare new methods and end-to-end methods against it. And we also see applications such as specifically in more regulated spaces like healthcare, where we need explainability. And end-to-end approaches often still lack a lot of explainability because you have a 300 billion parameter model and you don't exactly know what it's doing or why it's doing a decision. There's a lot of research on explainable AI and it's making progresses here. So it's very exciting to see that, but still, even with the latest LLMs and everything, we're seeing them fantasize, we're seeing them having situations that come up that we cannot easily control. And if we go into more regulated spaces or simply want to understand the algorithm to measure certain things from the voice or from an audio signal, then feature extraction, I think, is still a good point. And also, I think we still need something to teach the end-to-end models with. So you can also use openSMILE features for that, for example.
Oh, I see. And actually, how you moved from openSMILE to the audEERING company, and like what was the idea that led you founding audEERING company?
Yeah, I think that goes on the one side back to what I said about PhD before. I mean, I really liked it working in PhD, but then you publish something and the code does not really get reused. So that's why we made openSMILE open source, to have a chance that it continues living after I finish my PhD and people would still use it. Also then I sensed that I have to do more to actually bring the technology that I've developed during my PhD, the fields that I worked on, into practical applications, going more beyond a demo that you might do at a university, but bringing it into something that is being maintained and really being used at scale. And that drove me intrinsically to build up audEERING. And then it was also, I think, fortunate timing, more or less. So the idea came up 2011, early 2012, where also at TUM we had got some requests for more commercially aligned projects. And it was smaller projects. So it was not a 3-year research project or 1-year project from industry, but it was rather a small request. Hey, can you in a month build us this or build us that? Can you sell us some technology? And I think the TUM Technology Transfer Office was a bit overwhelmed and said, this is so small stuff. We don't really like to deal with it so much. Can't we have a bigger project? I mean, totally understandable. And yeah, it always depends on the scale that you think at. But then it was also the time when Siri came out as kind of the first voice assistant, more or less around that time. So we said, hey, there is commercial traction. The ASR market was moving into something that gets into our everyday lives and getting better than classical dictation systems, understanding what we want, enabling interaction. So we said, this is a nice time, and we took a quite different approach. I mean, normally you would say, okay, we write a business plan, we go to get VC money and we go pitch it everywhere, and then we grow this fast. But the time for what we were doing, this expression analysis, we felt it was not yet the right time to really rapidly scale big and fast, because still people were struggling with ASR, but still there were some research and POC requests. So we just took the chance to found a company and take the first projects to finance the company with it and build it, really bootstrap it from scratch. And that's what we actually did. So when we founded the company, end of 2012, we didn't really have any specific project. We founded it very small. In the first year, I think we did consulting, and then really quickly we got bigger projects in the market research field. We also got projects in the area of acoustic scene analysis, and kind of one project led to the next project, keeping us financed, allowing us to hire our first employees to the company, next to me being the actual employee number one. And then going on like this till 2016, 17 actually also, where we then decided now is a more dynamic time in the field and we need to scale. We met through our projects, strategic partner that also was interested in our technology, interested in investing in the company. And so we were then able to scale the team to a bigger size of around 50 to 60 people, more or less of what we're now. We're now around 70 people, to put more efforts into data collection, standardizing our products, but also having the, in industry sense, you must say luxury, to have a research team to enable us to stay at the forefront, try out new technologies, be still active in the community to support the open source community, continue maintaining openSMILE, and also do some validations and publications.
Cool. My next question is more like sounds like more a fun fact. Like, how did you decide to name the company? Because I tried to search like on the website and I couldn't find it. And it's like something I always do whenever I come up with a new company. Well, my road comes to a new company and I start searching for it. So yeah, what was the idea and how you decided to name the company?
That's also a very good point here. I can't say that, oh, this is a name that has a long history because of whatever story behind it. No, I think we sat together and say, okay, we're going to found a company. So how do we name it, right? Well, it has to do something with audio. So we were brainstorming around it. Machine learning, what's the names? And basically we were somewhere stuck then at audio and engineering. So I think at some point we contracted it together. We said audEERING, so it's the combination of audio engineering, and then also put it in this capitalization. So often people do this wrong, but actually it's AUD lowercase and then all caps for the earring. And that's also like we registered the brand, so it appears like this, but sometimes people just write it with a capital A and audEERING, but typically you would recognize the name as it's in the logo.
Yeah, perfect. And thanks also a lot for this nice and very concise but comprehensive overview over how the company got to be and how it developed in its initial years. And now coming to the current time, could you please give a brief overview over audEERING itself, and especially maybe which products it provides and how everything ties into each other at the company, basically?
Sure. As I mentioned, so starting 2018, we further refined and developed our product offering, and we now have one core product, which we call device. The spelling is a bit different than like a hardware device. It has a capital AI in there, of course, because of AI. And there's a nice, more or less inside thing that we always like to call it audio intelligence. It's also AI for our field, not overall artificial intelligence. So that's where we came up with the product name device. Why device, actually, also? Because our aim at audEERING is to run everything we develop, all our algorithms, on an edge device. So that can be a mobile phone or your computer, laptop, or any smart speaker with an embedded system on it. We don't want to make stuff that we have to rely on cloud connectivity, because we are processing audio data in its raw form. We might want to also process more than just recognizing a few commands with speech recognition. We might want to analyze longer episodes for acoustic scenes or also for speech expression to monitor the changes of your expression over the day. And that's where this needs to be running locally in order to preserve your privacy, because I think you could not persuade anybody to stream everything you do continuously on your phone to a cloud to be processed, even if the cloud would be secure. But even if you'd agree to it, it would still be a lot of bandwidth simply, and also cost on the cloud that you would have for it. So that's why we started with the mission cloud service. Okay, we can do it, but we want to make everything available on the device. Okay, now what does device offer as features? We try to tackle the full pipeline you need to get a random stream of audio, which basically can contain speech, but music and other sounds and noises, up to the point where you can analyze the expression of the speech in there, and also some other things like speaker attributes. So first of all, you need to detect, is it speech or other sounds like music or noise? Then you need to ensure that the speech you want to analyze has a quality that is sufficient. So is the SNR okay? Is there any reverb or any other things that could be problematic, like clipping? So we offer an audio quality module to assess that. Then we offer a speaker ID module. So to verify, is it actually a speaker that I'm interested in analyzing? In the case of monitoring you over a longer period of time, we cannot analyze speech of other speakers. It's you and your speech that we're interested in that case, and that you have also consented to when you use the application. So that's where we would need speaker identification. Or we might have a scenario where multiple speakers are speaking in a dialogue, in a meeting, in a discussion, and we want to analyze every speaker individually. Again, we need speaker ID or speaker diarization for it. That's what device offers. Then the next point is expression in voice. So we have a model here that uses from psychology the so-called arousal valence dominance model for the expression, where arousal generally gives the intensity or activation of your expression. So are you screaming? Are you really speaking super excited about something? Or are you somehow detached and passive, seeming bored, uninterested or something? That's the arousal dimension. Then you have the valence dimension, which indicates if something is positive or negative in your expression. And the dominance dimension indicates whether you are in control of a situation, if you feel confident, or if you're more unsure and overwhelmed by the situation. And all these things reflect in the expression that you put in your voice. And those are the three dimensions that we basically measure in our device product. Then we have a module about speaker attributes. That includes predominantly the age of a speaker, which we can estimate with an accuracy of around ±6 years. So roughly, you can think of it, the decade, is it like in the 20s, 30s, 40s, 50s, 60s, and so on. That's what we can estimate from voice. We also have a module to analyze the gender of the voice, although we know gender is a very diverse topic, so we like to call it biological sex. So basically, if your voice sounds male or sounds like a female voice. not making any assumption, of course, with the model what gender you identify with. So that's this offering concerning voice. There's a sidetrack in device. You find a module for acoustic scene analysis. So this enables you to understand from an audio signal the context in which you are. So are you in a quiet indoor environment? Are you in a more noisy indoor environment like a restaurant? Are you outside on the street where there's traffic noises? Or are you in a natural environment like a park where there are typical sounds? And typically from 5 to 10 seconds of audio, you can make a good assessment of what type of scene you are in.
Yeah, perfect. Thanks a lot for this overview over the core product basically from audEERING and how modular and flexible it is. Relatedly, we also saw on the website that there is a grant for young researchers or for researchers in general to obtain a device license. Could you please quickly elaborate on that aspect?
Sure. Device is, of course, a commercial product in contrast to openSMILE, which we completely open source for the research community. So openSMILE also, you can buy a commercial license for commercial use. So you can only use it for academia. But device, in contrast, is not easily accessible for academia. We offer licenses for academia, for research projects. So if you have a budget in the project, you can probably purchase a license for the research here. But we do want to also support young researchers like master students or bachelor students who don't have their own budget and who want to try it and use it more for their thesis, their personal projects. And that's where we're really looking for bright minds. We're looking for very interesting application and use case scenarios. And that's why we have put up this application process. So if you're really interested in using it, but you don't have any way to finance it, you're not working for a funded project, you're doing a bachelor's thesis, you can go to our website and you can fill out the application form and convince us that what you're doing is producing great results and will be a nice use case and application for our technology.
Perfect. Thanks a lot for elaborating and portraying this nice opportunity that you can give to young researchers or to academia in general. So could you also elaborate, please, on the aspect of healthcare research that is happening at audEERING?
So we do have another product in this space. So as I mentioned, device is the core product that encapsulates all the algorithms and AI models that we built. But then we operate a web platform which is called AI Sound Lab. And that platform actually was born during COVID times, because at audEERING, we've always been doing research with humans, with people, recording data, of course, with their consent, getting them in for some studies on perception and production of voices. And we could not do this anymore due to all the lockdowns and contact stuff. So we did this, like everybody was having Zoom or Teams meetings, we also did this remote. And we had the requirement to get high quality audio recordings here. So not to have anything like in Zoom or being compressed, but really have the best quality and also ensure that the settings and the environment is right automatically on the platform. So that's where we built AI Sound Lab as a comprehensive audio study platform. It contains all the features that you need to run certain recording prompts, the questions, we call them prompts, record the audio from the users, ensure the quality of the recording, and directly process the audio to extract certain audio features or also analyze vocal biomarkers. And then show a result back to the user, also show some results to the one who operates the study. We also have the whole thing of consent management. So when you register on the platform, we make sure that you're consenting and double opting in. When you are participating in a study, we inform you about all the things that we're doing with your data, why we're doing the study, what's the purpose of it. And you can always also see on this platform your data, delete it if you want, if you change your mind. So we're having full transparency here. And the whole platform really is a tool for research institutions, for ourselves at audEERING and also for universities to accelerate and also scale the research on specifically vocal biomarkers, but also on other aspects of speech interaction and speech production. And we're happy to offer this tool for that.
Actually, I get hooked by what you mentioned about the consent of the users in the AI Sound Lab. And actually, my next question is related to this. Like, speech analysis can be a very sensitive field for products. So what are particular ethical considerations and concerns? And how do you ensure that the data is protected and the users are safe from spoofing and stuff like that?
Yeah, that's a very, very important aspect. I mean, we live in times that are rapidly changing. If we look at what you can do with deepfakes and what actually, I mean, the biggest issue I see is that at some point we cannot be sure if we're actually talking to the person that we think we talk to, or that our identity is being misused in some way. So I think this is really something in the future that will be interesting. At audEERING and also in the research at TUM throughout all this way, we've been always very, very mindful of ethics and very considerate about this. I mean, in research projects anyway, you have to involve ethics boards. If you do clinical research, for example, at the company, of course, we value data privacy very high. And one of the aspects that we use or that we've built to be also more privacy safe here is the local processing. So I mentioned it before that we, for some applications that might contain more sensitive data or just simply a continuous recording of a private conversation, that we don't want to actually record this, that we don't want to send this to a cloud. So we try to minimize the data that we process and really process it directly where it is being recorded or captured, to not have any data being stored or sent to some location shared with third parties that we actually don't need to. So minimizing the risk here is really one of our strategies. And the other area is transparency and education. So educating our customers or educating also their end users and the public what this technology can do and what it cannot do. Because often we have the impression that there's a technology that can analyze our voices, and we're afraid that it can analyze and find out everything about us that we don't know, like a genetic test or something, which is not true. I mean, if you look at research now, I mean, we don't know where it will go to in the future, but I doubt it that we will be able, just from your voice, to find out something, some rich information like we get from your genes. Certainly, there are many things encoded in your voice, and you know that if you listen to a voice, like my voice in the podcast, or like some other random person calling you on the phone, you do hear immediately some items and you paint a picture of that person in your head. But then if you meet the person in reality, your impression of that person might not be completely accurate. If you know the person better, you might see that different things you had misinterpreted. So voice analysis is basically an interpretation that we do as humans. And the technology we're building is trying to mimic a human observer. So we're not trying to look, and we're not capable of looking into anything that nobody else would know about you or that you're not willing to share in some way. So we're very considerate about that. Also, when we talk to our clients about potential use cases, when we explain to them what the technology can do, cannot do, and also advising them on which use cases to use the technology for. And we would always also check what use case it is being used for. So there are some use cases which we would not license the technology for because it would be unethical, or also because we know that they have high expectations that the technology could do something which we know that it is not made for, not suitable, or not accurate enough. And that leads me to one of the topics that's very important. It's the fairness and bias testing. So when you build machine learning models, and when you're new to machine learning, the first thing you learn is you evaluate it for accuracy. Then you go a bit further and say, oh yeah, I can look at precision and recall and F1 measure. So you have a few metrics to evaluate. You look at the confusion matrix. But still, you're looking at accuracy. So how good is your model predicting what is in your human annotated ground truth? However, that's just one piece. But for voice processing algorithms, for image recognition algorithms, the fairness is very important. So is it treating different voices, different cultures, different speakers, different backgrounds? Is it treating them in the same way? Or is there a bias? For example, that women sound more positive than men or something like that. Or is the technology robust enough? So what happens if there's noise in the background? Does it change your result? Or is it stable? And for all these aspects, fairness, robustness, and correctness, which basically is the accuracy, we have built a very extensive testing framework. So that basically when we build a new model, we don't just say, oh, this is the best one that's accurate enough, but we run it through around 200 tests on the categories of fairness, robustness, and correctness to really check if this model is fair enough, if it has a certain problem that it's treating certain groups unfair. And that's very important. I mean, we're not at 100% so that all the tests are super fair and super good, but we have improved by quite a bit, 20% since we have implemented this framework. So that's quite a jump. And we also, first of all, know where the deficiencies of the model are. So we can give this to our customers and say, if you're using the model in a scenario like that or that, then it might not be accurate. So that they're aware of it, that we're transparent about this, and they can adapt their use case to it.
Oh, perfect. Yeah, thanks so much for this quite nice and great overview over how you take the concerns and especially the ethic considerations very seriously. And exactly what you elaborated on would have been our next question, right? Like we were also wondering, like, how do you account for different cultures, different confounding groups, basically. So thanks for taking our question there in advance, I would say. So now we would like to learn a bit more about your perspective on the whole field of speech research, speech analysis in the sense. One question here would be, if you would have a time machine and could go back in time, would you actually found audEERING again? And if so, what would you do differently maybe?
That's a good one. I think definitely yes, I would found audEERING again. I think what I would do differently from all the learning so far that I have, I would approach it a bit more with a commercial mindset for products. So we started the company, as I said, with projects. We were working for customers who needed a solution or actually wanted to have research. But I think the mindset should be, if you found a company, always to deliver a product or a solution to your customers. So see what is the problems, not just look at the technology and say we want to make great technology, which was our mission and which had worked out, but also to look at, with this technology, who has a need for it, who needs it, and then really actively go out to seek these people and sell them the technology. So putting a bit more effort in sales, moving quicker on this area. But also we have seen competitors in the field doing this probably differently, doing more the business mindset, going to raise venture capital and everything. But then we also saw that they went big very quickly and they couldn't sustain it because the market had changed. So I don't know if that strategy would have been the right one. So I think as we did it was very good. We had lucky moments. We had moments where we think we could have done it better. But I don't know if there would have been a much better strategy overall.
Yeah, thanks. That's always really tough to answer, right? But I think it's also quite valuable to have your hindsight, basically, especially being a founder and having sustained the company at least for more than 10 years by now, which is already quite some impressive feat in its own. So Maybe a very small side note for this. Would you also consider staying in academia in hindsight with a time machine? Or would you always go the way and found a company?
No, for me, I think only academia would probably be not an option, because I like to bring the products to the market and work on solutions for real world problems. The ideal thing, I think, would be somewhere in between. So either from the academia side, working a lot with companies who then bring this into a product. But as I initially said, I started all this because I also was a hobbyist in designing building circuits, writing my own code to do things, automating smart home stuff and everything. So I like to have things that provide solutions, right? That automate things, that make things easier. I was never the guy to say, that's a nice equation. I solved it a bit more efficiently on paper, but it's theoretical. So I always, also at university, I built demos. I wanted to see this work. I wanted to see this in action, hence also openSMILE again. So purely academic, probably not.
I really like your perspective, and I think our interests meet a lot, Florian. Would you encourage young researchers and potential founders to continue what to do actually after their PhD? Should they gain more experience from the industry and then, put all that knowledge back into the research? Should they continue their research and then try to incorporate industry? What would you advise them?
I think it depends on your personal preferences. I mean, I can't give a general advice, but maybe a few directions. So you can probably do a very good career if you stay in your research first and are really top-notch in your field. I mean, look at people who worked at academic research or at industry like Google and were inventing things like transformers or foundational technologies that now also shape AI research. They're very academically focused, but now also have great careers in the industry in some way. But it's more about, do you bring a mindset with you that you say, I'm just a theoretician, I'm a researcher by heart, and I don't care about money or business. So if that's your mindset, then it's perfect for you to stay in academia or go to a corporate research institute where you can do research. But if you also like to say, hey, I want to move something in the world, I want to create something, I want to make this applicable, I want to look at all the pieces. I mean, I want to do good technology, I want to do research, I want to innovate and try things out. But then I want to hold it in my hands and use it. And I also want to see how the whole market and the business works maybe behind it. Then yes, go found a company. The question is just, you need a good plan, you need a good idea for it, or at least already have a product or a good team. These are the ingredients. At least one of them you should have, maybe rather all of them. And also the question is, what makes a good team? So to your point, should we go first to industry and gain experience in industry, or should we directly found a company? Certainly, if you go to industry and work 3 years in a large corporation and do research, product development, you will learn a lot. And that can be very valuable for founding a startup. However, it's not a requirement, I would say. I mean, I didn't work in a big corporation or anything as a regular job after my PhD. But I must say I did, during my PhD, a bit unconventional, but I did 2 internships. I worked for Toshiba Research Institute in Cambridge, UK, and I worked for Google in the speech team, also in London. And I think those gave me a little bit of insight, it broadened my network through connections and meeting people to see how are people in a company operating, what is different than university. So I think that was valuable experience too. But if you don't have it personally and you have somebody on your founding board that has that experience, that has a business mindset, that also works. And the last important thing is the timing, right? So if you say, hey, now is an opportunity to found a company because you have found a niche in the market and you have a good business plan and you have a team that can actually do it and that you can sell, and you're finding investment money, or you can get a project and just start working on it, then do it now. Don't say, oh, but I have to go to industry first and work there 2 years and then we come back with our plan, because then you can be sure somebody else has done it. So if the time's right, do it. If you see, well, maybe it's a good idea, but it might only work out in 2 years, then go for a job, try to work maybe in that field and see what other people are doing, keep an eye on the field, and when the time's right, go and found your company.
Yeah, which was related on how you decide with who you're going to collaborate with. So I will move to our next question. How do you manage your work-life balance? How you prioritize your tasks? Because I can imagine you are pretty busy bee.
The thing is, if you do something that you love, that you like, then it feels less like work. So if you're doing something that you don't like, then you're working 40 hours a week or more. But if you do something that you like, and if you have flexibility in doing it, and also a diverse task, then it doesn't feel like working a lot. So some people say I work a lot, then sometimes I have the impression too, because obviously always there are tasks that you don't like. I mean, it's part of every job. Even if you have your own company and do stuff, there's always stuff you like more or you like less. But then you still focus on the things that you like, and I value very much also flexibility. So, I mean, if you manage and try to coordinate people, you have to be also in the tech field reading trends and being informed what is happening. So it's not a 9-to-5 job where you sit in the office and then you go and do something, but you read papers, you read literature, you inform yourself, because this interests you also. So it's that way part of your life. But of course, on the other hand, I also have time that I spend with family and that I don't think about work. And I think this is very important. So that you can actually just also say, no, I'm going to take some time for me now. And you organize the work in a way that you prioritize the important things. So I look for the deadlines that are immediate. I look for who needs my feedback, who needs my input. Where is it urgent? Where is it kind of a blocker? I mean, this is typical management, right? So you prioritize the things that would otherwise delay things and move forward. And then I think one important bit of advice in terms of work-life balance is, I think sometimes in the tech field, AI field now, you might be overwhelmed, because if you start reading papers and citations and everything, then there's every day a lot of papers coming out. Look at proceedings of interspeech, look at proceedings of ICASP and everything, many papers. I think nobody reads all of them, right? So don't try that, to read all of them. It will make you crazy and you will burn out. On the other hand, of course, there will be key papers. But I think one interesting thing is, I mean, I have the lucky and good situation that I'm working with a very good team at audEERING, with people like Pascal and many others who share the work. So they read papers, they come across some things. We discuss this, we share the information, we share summaries of it. That will help you keep track of all this impending, many things. And then also sometimes it seems like things are moving really fast and people are discovering amazing things, which certainly they do. But often, if you then look, what are they really doing? It's a lot of marketing also sometimes behind what you nowadays see in the AI hype. So that the technologies are not changing so quickly. I mean, just look at the fact, I mean, this is very simplified now, but just look at the fact ChatGPT still uses transformers in some way. So it's not a completely revolutionary new architecture. It's always bit by bit increments. And that way it's easier to keep up with it.
Yeah, perfect. Thanks a lot also for this quite valuable advice, be it for like young people that are looking for some career path after PhD, and especially also like for maintaining sanity with a good work-life balance. I think this is quite some good insights that you have.
Work-life balance, especially very important advice. You need to take time for yourself, so you can work better if you're relaxed. So there are days and weeks where you work till late at night and get things done. I like that too, because you get into the flow and you just really get things done. But then you sometimes have days we say, there's other stuff, you're distracted, you're not so productive. Then just take the time to do other stuff and get it done. And then you are free again to focus and actually get into the flow and do stuff. Because otherwise you're feeling totally stressed at the end of the week. You've just worked and done a lot of things, but you have no outcome. So try to maximize your efficiency when you do things, but take your energy from the times where you take breaks.
I'm super happy for whatever you just said, Florian, because it's quite inspiring to listen one more person to advocate like good work-life balance.
Yeah, I think it's really important. I mean, it does not mean that we should be lazy or not work, because also there's a lot of competition in the market, but really viewing it in a positive way. I don't know who said it, but it was a researcher at a conference who's talking about stress and health. And they said, well, we typically say stress is bad for your health, so you should avoid stress. But the new findings actually were that stress is only bad if you think it is bad. So the researchers have been telling you stress is bad for you, and that's why it's unhealthy for you, because that negatively stresses you. Say, hey, I'm stressed, I'm not feeling good. But stress itself is not anything that's directly impacting your health if it's positive stress. So if you're in the flow, if you're positive about something, doing a lot, working long, and you're happy with it, it can still be okay for your health. But to enable that, you need breaks, you need balance, and that's very important. Great that you see it the same way.
Okay, another question, a little bit more personal. Does your present life meet the dreams of your teenage self?
It's a good question. My teenage life has been a while in the past. But during my teenage life, I have been programming. I've been a bit nerdy, I guess. I've been building some technology and soldering circuits. That's not what I'm doing anymore. Yeah, probably like everybody, I dreamed of just being on an island and not having to do anything. But no, I mean, everybody knows it's not realistic. Jokes aside, but yeah, I think that's the interesting aspect is, when you go to university or during school, you think about, what are my options? Like career, you look at, can I be this? Can I be a pilot? Can I be a policeman? And you read about those jobs and think about it. Sometimes I hear people discussing about that, and also during university, did you go to career festivals, and do you look at this and you look at this, and have you gone to open house days of 10 companies and something? No, I didn't do it really. So I felt a bit guilty and said, well, maybe I should do more, right? But on the other hand, I don't regret it, because I just did some things that I liked. I had the coincidence to turn it into a thesis at university, and also study, actually, when selecting what I wanted to study that what I liked, and at an excellent university too. And then just my career path unfolded, and I never forced anything. I took some chances as they were, and I liked it, and that's how it so far was.
Oh, perfect. Yeah, thanks. That's quite some feature to be clean with your actions. And like, especially if you're dreaming as a teenager, there might be some divergence later on, but I see your point, and it's cool that you enjoy what you're doing. So relatedly, do you have any hobbies that you used to do as a child or a teenager and that you are still doing nowadays as an adult?
Yeah, one I had mentioned, like indirectly, right? Dance style recognition, being a hobbyist DJ. So it came all about that I started doing in my teenage times some classical dancing lessons with like everybody who was doing that at that time from my friends in school. Again, I was not so much fascinated in being a perfect dancer or anything like that. I was good at it. I enjoyed it. I enjoyed moving to the music, but I also enjoyed the technology and everything around it. So that's why when the place I went to do dancing, they organized like a DJ contest, because they have a lot of teenagers and young people that started there with dancing lessons being DJs. And I participated in that, of course, because I had already been asking the existing DJs a lot of technical questions along the way. And then it was naturally for me to participate there. Then led to that passion of DJing a bit, just on the side, for the dance parties or sometimes at school or something. And I enjoyed that as a hobby alongside the dancing. Then another one I mentioned, I did programming, putting circuits together and everything. So even before I, at university, really did signal processing algorithms for tempo estimation and everything, I already had this as a hobby to actually write some computer code to do animations for light effects to music or something. So I started implementing actually a filter bank as a teenager to say I can get low frequency, mid frequency, high frequency or something without any knowledge about digital filters or signal processing, more or less. So actually I think it was during physics when we had like some RC circuits that would do some low pass, high pass or something, or I just not Googled, but what was it at that time? Yahoo or whatever. Tried to implement something. So maybe I just should have Googled for digital signal processing. It was all out there. But anyway, I mean, I was young and naive, but it worked, and it somehow did some light effects, and I built some circuits. I had some external relay board. At that time, we still didn't have USB, so it was this kind of old printer interface, like LPT port or something. And that was then controlling some board with some relays which could switch on and off some actual 12-volt lights or something. So that was one of the passions, like building such stuff, and also generally experimenting with solar panels. I mean, you get them when you have these electronics experiment packages for children and for teenagers. There's maybe a solar panel, you connect a motor to it. That also fascinated me. So basically I could have also gone into the renewables energy sector. But nowadays, I mean, this is also still very, very current. And I think as a teenager, I had powered like a radio, which is battery powered. I had just connected solar panels to it and then used it just with solar. So just a few nerdy things. And well, now I have my solar panels that power my house, like everybody. So it's nothing special anymore. That's kind of a hobby that I had back then and that I still like nowadays.
Actually, it feels like your childhood shaped who you became. Somehow, I don't know, through your hobbies, I see it, through your teenage dreams, I see it. And you actually twice you mentioned that you were quite nerdy. So usually nerdy comes also with superheroes. So I don't know if you were very into them or my next question is more like, do you have a favorite hero, or at work would you be like more like Flash, Iron Man, Superman, Batman, or Hulk?
I think I'm very non-typical in this sense that, I mean, I've been nerdy for the tech and everything or working with it in some way, but not at all into superheroes or all these things like Superman and everything. So I think I was really not into all of that. I also was not into, I mean, everybody in the tech space is more or less gamer, doing ego shooters, role-play games and everything. I was also a bit different there. I mean, I did play a lot of computer games. I loved Flight Simulator. But I was not into the, like, you know, with violence and shooting and that stuff. I was not really, and I'm still not that guy. So I loved more like strategic games. Like there was one called SimCity, I think, where you build cities, where you kind of connect things, do some logic stuff and everything. That's what I really liked. So yes, technology, but not really the fighting superheroes and stuff.
Yeah, well, it was not that much about like if like the fighting part. It was more like about what they could represent or what type of superpower would allure you more. But yeah, thanks for answering it so well.
Well, yeah, I mean, as I said, I was not into the superpower so much, so I couldn't tell you now exactly which character would match me, because I don't deeply synchronize with them. But I think overall, I mean, if there would be a superpower or something that I would think could be beneficial to the world, then overall, I think, I mean, yeah, teleportation is always nice and handy, right? But on the other hand, I mean, healing diseases or something would also be a nice superpower. So I think.
Yeah, very good call. Yeah. Especially immortality comes up as well then as a thought. But
yeah, but then it gets very philosophical.
So yeah, like speaking about superheroes again. So if you were an actual superhero and about to save the world, with which of these two extremely powerful gadgets would you try to save the world? So on one hand, you could have state-of-the-art automatic expression recognition, and on the other hand, you could have state-of-the-art TTS. Which one would it be?
Well, I have to say expression recognition, but also I think it makes a lot of sense. So if I'm a superhero to save the world, what I would need to do is I would need to understand human beings, and I would need to very, very intelligently interact with them, because talking, negotiations, empathy is a key to accessing people and to moving things forward. If I have state-of-the-art TTS, yes, maybe it could help me to express myself and be heard. But on the other hand, if I cannot detect what people are saying, if I don't get the message, if I don't get sarcasm or irony or anything, I might have a bigger problem. So both of them are somewhat important, right? If I sound crappy, I probably cannot show my empathy to somebody. The more I think about it, the question gets harder, right? But still, not just because of my background, right? But still, I would stick to the detection side, because there are many ways of expressing and acting. I don't just have to speak. So if I just passively listen in, I could still on some other grounds act by using magic or by doing something without speaking. So, but if I cannot see or I cannot recognize what's going on, then I can be as good as I want to be at expressing myself. It would not help.
Cool. Thank you for your answer. And let's move to the next one, which is what is your ideal summer vacation? An isolated island where you can listen only in nature, a busy city where you can't hear even your thoughts, or the relaxed environment of your home?
It has changed a bit as I have kids. So the ideal summer vacation is something where everybody's happy, right? That means yourself and the kids are happy and taken care of. But overall, I do prefer nature and more private settings over a big hotel with a lot of tourists. So that's for sure.
Then coming toward the end, we had in our last episode Matt Kohler on the show and asked him what he wanted to ask our next guest, which is you. And his question was, what will the future of speech technology look like in the following 50 years, and how can we achieve that?
The next 50 years, that's very long. I mean, you're always tempted to look at the past and say, how has everything evolved, right? And how will the next 50 years be? I think right now we're at a stage where a lot of things that 20 years ago seemed very difficult and in early stages have been solved. So something like ASR, TTS, it might not be 100% solved, but we can use it. So I think nowadays nobody thinks about, hey, is the accuracy of the ASR enough if we talk about a commercial application? We see it is not perfect, and in some scenarios it's not getting things right, but humans are not perfect. TTS is making mistakes, but we're there to just use it. So we've arrived in a world now where computer voices sound like human voices. We've arrived in a world where the computer can understand us, and large language models like GPT-4 have just done the understanding part of it. And in terms of speech technology, I think it has to be viewed as a more holistic thing. So it's not just looking at an ASR, because obviously there are end-to-end models and there will be end-to-end models. So in 50 years, I think we will be definitely at a stage where we naturally can use speech to interact with our gadgets and technology, where we move away from the smartphone screen, where we move away from apps and just typing. However, I also believe from a use case perspective that although I work in speech and everything, that not all the use cases will be done by speech. So just imagine you are in an airplane, you're in a subway, in a train ride. Would you do all the interactions with your smartphone only by speech? No, probably not. So you might feel comfortable in just typing a message and having your privacy here. But then if you're in a private environment at home, you don't want to do a lot of cumbersome typing or issuing some commands to a stupid smart speaker. You would just like to talk to any assistant or robot or anything that might assist us together naturally and just say a few words, or maybe just say, oh, or something, and then have the system understand what you want and know your preferences, right? And really provide the right thing. So I think it's hard to just see speech alone, but to see the whole technology advancing. And maybe that also then leads me to my question for the next person, but I'll save this for a while. So speech in 50 years, I think it will not be a very big research topic actually anymore, because most of the things will be solved. I see potential in the medical area, so that we dive deeper, understand human voice production more, and how it is connected to our brain and everything. I think the understanding side will make a major leap here. In terms of technologies, it's more on connecting everything. So on the brain side, the LLM side, enabling everything to be end-to-end, simply having this available just like we have a keyboard today, and like this has become natural and everywhere. That's what I think we'll have in 50 years, that the children in 50 years will not say, oh, talking to a computer is something that's talking to a computer. It's just completely natural. I mean, we're seeing this already nowadays. But we won't question and we won't know a world where we have not been able to converse normally with machines. That's what I think about 50 years. But still, probably we will see, hopefully, that it's machines. And we will be aware of it, because this whole topic, how much control should we give an AI, or how should we stay in control of things, and how ideally should we use AI just as a tool, which I think we should. So it's a tool for us and not something that we give control to. And that again is in our control. So that's what I believe.
Great. Now it is your turn to ask something to a future guest without knowing their background.
Yeah, so my question to the future guest would then be, in 50 years, will we have AGI, where AGI is artificial general intelligence, or is that ever possible?
That is great. We reached to the end of our long list of questions, and I think it is time to thank you for joining us today, Florian. We learned a great deal about you as a researcher and professional, and I hope you enjoyed our discussion as much as we did.
Very, very much. Thank you so much for inviting me. I had a great time, and I hope I could give some valuable advice to students and other people in the community.
Yeah, and thanks a lot for listening, and stay tuned for future episodes of Speech Pitch, as we might interview your favorite speech researcher.